activity number 2. It is grade 7 advanced post-course test. And question number 1 is dealing with solving for the variable. So we have two variables on the same side, and you've got a constant here equaling a constant. So we're going to combine. We always want to simplify first. Whenever we have equations, you should always simplify each side first. So we have like terms here, so we're going to add that. That's going to be 3/5 x minus 12 equals 3. Then we're going to move the constant over. Our variables are consolidated on the left side, so we're going to push our numbers to the other side. That leaves us with 3/5 x equals 15. We have 3/5 times a variable. We could divide by 3/5, but that would be really ugly, meaning it would look like this, because that would be the inverse of multiplication is division. But who wants to deal with that? That looks yucky. So there's a much more efficient way when you have fractions. The other inverse of multiplication is multiplying by the reciprocal. The reciprocal of 3/5 is 5/3. These cancel, leaving us with 1x or x equals, and we're going to cross cancel. We're not going to multiply 15 times 5 and then divide by 3. Let's simplify this denominator with this numerator. There's a common factor of 3 goes into 3 once. 3 goes into 15 5 times, and now we have 5 times 5, which leaves us with 25. So x equals 25 in this example. Now we have multiple steps. This is called multi-steps. Our variables are on both sides of the equation. So we again will choose to simplify by distributing each of these values out. That's 5 times. This is -6 times. So you have -6 times 8 minus 6 times -7x. -6 is being distributed to each of the terms, 8 and -7x, and that's going to equal 5 times 7x plus 5 times -4. Make sure that negative stays with the 4. We are distributing out a positive 5. These must be positive 5s. So -6 times 8 is -48. -6 times -7 is positive 42 equals 5 times 7x is 35x. 5 times -4 is -20. We're always going to move the variables first. We want to move and combine variables. I have them on this side, this side. I have to get rid of the 35x on this side. What gets rid of a positive 35x? A -35x. And we're going to balance that equation by doing it to both sides. These cancel. You're left with -48. And this is going to leave us with, these signs are different, so we're going to subtract that. And that gives us positive, what's that? 7x equals -20. These cancel. And now we've consolidated our variables on the left side, so we're going to get rid of our constants on the left side. What gets rid of a -48 is a positive 48. Let's balance the equation. You have 7x equals, and that's going to give us positive 28, and because that's 48 and -20 gives us 28. We're going to divide by 7, and x equals 4. Nice, efficient way of going about solving multi-stepped equations. How many solutions does the equation have? Well, what they're talking about here is you can have one solution, just like this. You can have no solutions, or you can have infinite many solutions. So we'll notice here is we're going to end up simplifying, and if our variables cancel, if you can isolate variable, and you have a coefficient in front of that variable, you're going to get one solution. If you isolate the variable and your variables cancel, if your variable cancels and you get a true statement, well, that means infinite many solutions. That means all real numbers. Every number is a solution. If your variables cancel and you get a false statement, meaning your number statement, if your variables cancel, you're left with numbers. So if it's a true statement, like 2 equals 2, then you have infinite many solutions. If the variables cancel and you're left with a false statement, like 0 equals 2, that is no solution. So no variable, no number would work as a solution. Now, if you isolate the variable and the variable doesn't cancel, you're going to have one solution. So let's simplify this. We have negative 1/5 times 25x plus 10 equals negative 2 minus 5x. So let's distribute this negative 1/5 into that. That's negative 1/5 times 25x minus 1/5 times 10 equals negative 2 minus 5x. Okay, so these are going to cancel, denominator, numerator, so that gives us negative 5x. This is going to cancel also, denominator, numerator, and that's going to give us negative 2 equals negative 2 minus 5x. We're going to move the variables. Always move the variables first. So I'm going to move those. They cancel out, and they give us a statement, negative 2 equals negative 2, which is true. It's a true number statement. So my answer is going to be infinite many solutions, meaning every, or other math books will give this answer, all real numbers, because that explains the set of all real numbers are the solutions. Every number works. If you plug in 1 in here and simplify the left side, plug in 1 here, you're going to get negative 7 equals negative 7. So it's a solution. So those are the 3 options for this, and that's how we come up with it. Number 4, the vertices of a triangle are A is negative 4, 1, 2, 3, 4, positive 3. So negative 4 on X, positive 3 on the Y. My B value is negative 1, negative 2. That's my B value. And my C value is negative 3, negative 1, 2, 3, negative 2. Okay, so it looks like that. That's the C value. So, and it's a triangle, so we definitely are going to connect these. That definitely is happening. Let's do green. Let's do green. Let's connect them. So we have this triangle that looks like that. Translate the triangle 3 units to the right and 1 unit down. What are the coordinates of the image? So you can do it in a number of ways here. We can take this and we can take the point and we can go right 3 and down 1. So right 1, 2, 3, down 1 takes us here, and we call this A prime. We can take this point and go right 1, 2, 3, and down 1. And that gives us our C prime point, and we can take this point and go right 1, 2, 3, and down 1, and that's going to be B prime. And now we can connect those dots. Let's make that blue, and we can connect them, and it looks like this. That is our transcribed. What are the coordinates of the image? So now we can write each of the coordinates. Whoa, sorry. So A prime is going to be negative 1, 2. B prime is going to be 1, 2, 1, 2, 3. So 2, negative 3. And C prime is going to be 0, negative 3. 1, 2, 3. that's one way of doing it. We can also, the translation or the transformation is going to be x plus 3, because that moves it to the right 3 units, and y minus 1. So that is how we would transform it. And then you could take the values, the original values of -4 plus 3, comma, 3 minus 1. So we're putting our x value and our y value into this transformation or translation, and that would give us, so that is -1, 2. And we notice -1, 2. So that's the other way you can do that mathematically. Okay, what are the coordinates? These are the coordinates of the image. The vertices of a triangle are -4, -3, -3, -1, and -1, -2. So let's do those. So -4, 1, 2, 3, 4, 1, 2, 3. That's going to be A. B is -1, 2, 3, -1. That is B. And C is -1, -2. That is C. Let's connect the dots. They did not remember us. So let's connect them. Boom, boom, boom. And reflect the triangle in the y-axis. This is the y-axis. What are the coordinates? So we're going to reflect it. Let's draw a reflection line just so we know what that looks like. So we're going to reflect it over the y. And so that's going to take us to, so if we go, it's going to have the same y value. It's just going to reflect its x value. So this is going to be C prime. And the A is 1, 2, 3, 4 away. So 1, 2, 3, 4 away. That's A prime. And B is 1, 2, 3, 1, 2, 3. So that'll be B prime. And we can connect those dots. Nope, that didn't work because we went to that blue. And let's connect them. Good. And then it says, what are the coordinates of the image? So the coordinates, A prime is going to be 1, 2, 3, 4. 1, 2, 3, 4, -3. B prime is going to be 1, 2, 3, -1. And C prime is going to be 1, comma, -2. And if you want to use the transformation, the mathematical, when you reflect over the y-axis, your points, your x values is going to be the opposite of your x value, comma, y. So you plug in these values in for x and y, and they create your points. So that is a reflection over the y-axis. The vertices of a triangle are 3, 4. Let's get our colors. 1, 2, 3, 1, 2, 3, 4. That is going to be A. B is 4, 2. 1, 2, 3, 4, 2. That's B. And C is 4. 1, 2, 3, 4, -1. What? 4, 2, 4, negative. The vertices of a triangle. That is an ugly triangle. 3, 4. That's right. 4, 2, 4, -1. Ugh. That's not very kind. That is not a fun triangle to be drawing, or rotating for that matter. That's not very nice. Okay, rotate the triangle 90 degrees counterclockwise around the origin. So it's going to go around the origin. We're going to rotate it 90 degrees off of that. So we can look at it in this manner. We can take that, let's make it dotted. So we can draw a line to the origin, and then we want it 90 degrees off of that. So it's, it's something like that where it's a 90-degree angle. So you'll notice that you're going to get something like that. 1, 2, 3, 4, 1, 2, 3. And that point is actually going to be the reflection. So it is -4, 3 is going to be A prime. So when you rotate it 90 degrees, this is 90 degrees to the origin. So we're rotating it and counterclockwise, going backwards. So each of these points are going to be reversed or exchanged and the opposite. So it really is the opposite of y, comma, x is what you do. So my B point is going to be my A prime, ended up being -4, 3. We flip them and take the opposite of my y. My B prime, let's flip it and take the opposite. My C prime, let's flip it and take the opposite of my y value. And those are the 3 points. So -2, 4, 1, 2, 3, 4 would be my B prime. Let's erase this. We can get this out of the way because we have a record of it. And my C point is 1, 4. Boom. And kind of looks like it, right? It looks like it should be how we expected it to be. So we've got that really, really tight point, and that's that. Good. And if we drew those diagonal lines again, like we had, and that is like that. And so if I drew this to the origin and then up, you'll notice that that's 90 degrees. We draw this to the origin and up, and that's 90 degrees. So it holds true of that rotation, counterclockwise 90 degrees. Good. So that's something you should know also. I guess that's 7th grade. You'll definitely work on that maybe in geometry. So this is triangle MNP is the image of triangle JKL after a translation of 2 units up. JKL is scalene. A is the measure of angle K. Question A. Is the measure of angle K equal to the measure of angle P? Well, let's check it out. So first of all, it's scalene, so that means 3 different side lengths. Is the image of JK alpha translation. So, well, we know that if triangle MNP is similar to triangle JKL, we know that these correspond. So M corresponds to J, N corresponds to K, and P corresponds to L. And then angles also hold true. So if we have triangle, we'll draw just a pseudo triangle. So MNP, then our triangle is going to be JKL. So angle J is going to be congruent to angle M. So is the measure of angle K equal to the measure of angle P? No, especially if it's scalene, right? That means 3 different. So no, A is no. That's a big no. Is the length of side KL, so KL, equal to the length of PM? Nope. KL corresponds with NP. So that's also no. So corresponding angles, corresponding sides, corresponding all these things. So when we say angle MPN, you're talking about angle JLK. Corresponding parts, corresponding pieces. Line H and line T are parallel. Both lines are rotated 90 degrees counterclockwise around the origin. Are the images of the lines parallel? Yes, they're parallel to begin with. If you have 2 parallel lines, so if you have a line and you have a line parallel to it and you rotate it, it doesn't matter where that, let's make it a little bit. If we rotate it around the origin, well, let's take some points here. Let's do this. We can get really specific. So let's do this. Let's do this, yeah. So that's good. Let's make this also has a slope of 1. That doesn't look like a slope of 1. That kind of looks like a slope of 1. That looks better than a slope of 1. So slope of 1 looks like that. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. These are up 1, right 1, up 1. Well, we can move that over a little bit. That's up 1, right 1, up 1, right 1. So if I rotate, let's take a point, and we know about rotating at this point, at this juncture. So if we rotate these 2 points, this point is -1, comma, what's that, 7. And this point is -1, 2, 3, 4, -4, comma, 1, 2, 3, 4. So if we rotate this 90 degrees, we know what that, we call this point A, point B. Point A rotated is going to be -4, 4. No, -4, -4. Sorry, 1, 2, 3, 4, 1, 2, 3, 4. That's going to be A rotated. And let's flip and change. That's -7, -1. 1, 2, 3, 4, 5, 6, 7, -1. That's going to be point B. And if we connected those, that's going to be the line rotated 90 degrees. Now let's take points from the other line, and let's take that point, and that point is 1, 2, comma, 1, 2, 3, 4, 5, 6. That's going to be, we'll call this C. And let's take this point, which is in the other quadrant, and that's -2, 2. We'll call that point D. Now let's rotate it. So we're going to flip it and change the -y. So that's -6, 2. So 1, 2, 3, 4, 5, 6, 2. Oh, that's going to be C prime. And that's going to be -2, -2, which is here, right? -2, -2. Yep, that's good. That's D prime. And if we connect that line, notice they are still parallel. So we just proved it by, yes, are the lines still parallel? Yes, they are. Awesome. Took a little time, but this is good practice. You translate a line 2 units left. Is the image of the line still a line? Yeah, just because you translate it. Let's take this line. Let's take a line, and let's translate it 2 to the left. If we take this, let's do this. This will be fun. We'll copy it. Copy. Let's paste. So it's on. So if we translate it 2 to the left, is it still a line? Yes, it is still a line. Yep, it's just, and it'll be parallel. So yes, and those 2 lines will be parallel to each other. The vertices of a triangle A is 3, -3, 1, 2, 3, 1, 2, 3. That is point A. B is 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. And C is -6, -6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's going to be point C. So let's connect them. A, B, and C. Dilate the triangle using a scale factor of 1/3. Okay, so that means it's going to be 1/3 the size of it. So each point is going to get 1/3 of its value. So if A is 3, -3, and we take 1/3, so we're going to do 1/3 X, comma 1/3 Y. So we're going to take 1/3 of that. So A prime should be 1, -1. If B is 6, 3, then B prime is going to be 2, comma 1. and C is -6, -6. C prime is going to be -2, -2. And now we can draw those. I don't know if what are the coordinates? Well, we have the coordinates. These are the coordinates, but let's draw it. So A prime is 1, -1. That is A prime. B prime is 2, 2, 1. That's right there, B prime. And C is -2, -2. And that's C prime. And we can connect those dots. And we're going to get an object that is similar. It's proportional. So it's proportional in all of its aspects. Good. Number 11, describe the sequence of rigid motions. Okay, so is it a rotation? Is it a reflection? I see 2 reflections. I also see a rotation. So I think it's 2 things. You can either say it's rotating. So rotate, I don't know which one is the original. That's the unfortunate part. But it rotates 180 degrees around the origin. And if this is the original, we can say counterclockwise. Okay. We can also say it reflects. Another answer is you can reflect it over the y-axis. So if this is my y-axis and we reflect it, you would get these points. Let's do it in green. So you get this, this, and this. And it would look like this. And then you would have to, so you can reflect over y-axis. And then you would have to reflect it over, I think it's not the x-axis, x minus 1 or something like that. So that would be interesting. You'd keep your x and flip that over x -1. I don't know that one. I'm out of practice of that. But you would flip it over this line right here. So then you'd have a reflection. I don't know if you could say this. A reflection over y = 1. Excuse me. You would reflect it over that. So maybe reflect it over y-axis, then reflect it over y = 1. I like that. That might pass. Reflect, but this is sort of what we're working with. Reflect over y = +1. The equation y = 1. Let's see. Yeah, I think that's good. So you're rotating it. Oh no, that's not a rotation. So if I rotate it, it would actually be over here. And then you have to shift it up. So that's actually not true. If I rotated it, it would have come down here. So that was actually incorrect. So you have to rotate and then shift up. So let's get rid of that. Delete. Let's delete the reflection. Let's get rid of this. So we're gonna rotate it 180 degrees, takes me to here, and then we have to shift up. Then shift up 2 units. Yeah. You're going to have to add 2 to all your y values only. All right. That's a tricky one. Describe the similarity transformation. So that is definitely going to be a shrinkage. Scale factor. I'm assuming this is the original. So if this is the original, we're actually scaling up or increasing. I guess A, we'll call this A. This is B, and this is C. So A looks like it's 1, 1. B looks like it's 2, 1, and C looks like it's 1, 2. And then the transformation, this is A prime, this is going to be B prime, and this will be C prime. So it looks like it's a dilation increasing. So let's like A prime is 3, negative 3, 3. B prime looks like it's negative 6, 3. And C prime looks like it's negative 2, 6. So we're going to increase by 3. So it's definitely a dilation of 3. But we also have to reflect it over the y-axis. Yeah, and dilation of 3 and reflect over y-axis. So this one is the y-axis. So we can either reflect first and then dilate, or either one. So we're going to take each value and we're going to make 3x comma 3y. Okay. And that would give you your point. And then if you really want the formula, you would just do that, because that's the reflection over the y. It's just the opposite of x. So that would be your formula for your translation. Yeah, that's 12. 13, find the measures of the numbered angles. So we have to know that when we talk about parallel lines, these little arrows, these little triangles here, tell me that lines M and N, M is parallel to N, and P is going to be the transversal. So we have lots of things. We have things that we should know are called vertical. Vertical. I don't know how you spell vertical angles. That's probably not vertical. I think there's an A in there. Vertical. Vertical angles. Vertical angles are, for example, angle 2 is equal to angle 3. Those are vertical angles. Angle 1 is equal to 103. Those are vertical angles. Angle 6 and angle, that's not an angle sign. Angle 7. Those are vertical angles, and angle 5 is equal to angle 8 because they are vertical angles. That's one very important thing. Then we have corresponding angles. Corresponding angles are like on a clock. If we look at the top left of this intersection, it's the top left of this angle, of this intersection. So angle 1 is equal to angle 5 because they're corresponding. Angle 3 is equal to angle 7 because they're corresponding. Angle 2 is equal to angle 6 because they're corresponding. And angle, or 103 degrees, is equivalent to angle 8 because they're corresponding. And now another one is alternate interior. Alternate interior angles. So they alternate on the interior of your two parallel lines, and they alternate on it. So angle 5 is equal to 103 degrees because they are alternate interior. And angle 3 is equal to angle 6 because they are alternate interior. You have alternate exterior also, but I don't think they teach that in 7th grade. And then you have the last one is you have supplemental angles. So supplemental, you have angle 1 plus angle 3 is going to equal 180 degrees. You have angle 1 plus angle 2 also equals 180 degrees. You have lots of them. You got 2 and 103. Angle 2 plus 103 is going to equal 180 degrees. And you have 103 and 3. So angle 3 plus 103 also equals 180 degrees because they are supplemental. So find the measures of the numbered. So let's do this. Angle 1 is going to be, let's do this. Angle 1 equals 103 because they're vertical. Angle 2 is equal to, well, that's 180 minus 103, so that's 77 degrees because they are supplemental. Angle 3 is equal to 77 degrees because these are supplementary. They add up to 180 degrees. Angle 4 we don't have, so angle 5 corresponds with 1, so it's 103 degrees. Angle 6 is alternate interior to 3, so angle 6 is equal to 77 degrees because they're alternate interior. Angle 7 is equal to 77 because they're vertical with 6, and angle 8 is vertical with 5 or corresponding with 103. So those are our measures of our angles. 1 is 103, 2 is 77, 3 is 77, 5 is 103, 6 is 77, 7 is 77, and 8 is 103. Find the values. So the sum of any triangle, the angles of any triangle, is always going to add up to 180 degrees. So you have 48 plus 95 plus your missing angle is going to add up to 180. So we'll add those together. Remember, we always simplify. So that's 143 plus x equals 180. We will subtract 43, subtract 143, leaving us with x equals 37 degrees. And that missing angle is 37 degrees. Same thing here. The sum of these will give this a question mark. So 56 plus 69 plus the question mark should equal 180 degrees. We'll add these together. That's going to be 125 plus the question mark equals 180. Well, minus 125 minus 125. And you get the question mark equals, that's going to be 55 degrees. Okay, so this missing angle is equal to 55, and we know that these are supplementary. So we know that x plus 55 is going to equal 180, and x plus, oh my goodness, yes. So you're missing, your x is going to be 125 degrees. Don't know if you know this. This is also in geometry that you will find is this angle is going to be equal to the sum of the opposing other two angles. And that makes sense. If this equals 180, right? The sum of these equal 180, these equal 180. Well, all you have to do is translate, or what's it called? A equals B, B equals C. What's that? Transitive property, that's the word. So you use the transitive property or substitution. Boom, that's it. Okay, so hopefully all worked out. That's page 1.